Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of August 11th this time around. So we start out with quite a bit of moon. On the night of the 11th into the morning of the 12th, the moon is about 90% full. And it sits on this first night about 5 degrees southwest of Saturn. And so we've been tracking Saturn. Saturn doesn't move really quickly across the sky against the background stars, nor does it Neptune. And we've been tracking these two. They've been sitting together. So Neptune sits just north of Saturn. Great time to get your binoculars out, get a small telescope out, and find Neptune sitting a degree or so north of Saturn with the moon there about 5 degrees away. The bright moon will wash Neptune out a little bit, make it a little bit hard to see, but I think you'll be able to see it. The next night, the moon will have moved over to the other side and will be sitting about 10 degrees on the other side of Saturn right there. It'll be down to about 80% full. And as the moon moves on and wanes away, it'll be easier and easier to see Neptune there. So use the opportunity to identify Saturn if you haven't identified Saturn in the sky. Look at Saturn in your small telescope and then keep coming back as the moonlight gets less and less and less obtrusive. See if it's easier to see Neptune there with your binoculars or your telescope. By the end of the week, the 17th and the morning of the 18th, and we're really talking about the morning of the 18th right now, the moon's all the way down to a quarter full. And so we got a nice thin crescent moon, and it will have moved across the sky, be rising about 1 o'clock in the morning, depending on what your horizon's like, what your local area is like right there. And it'll be very near Elnath. It's our old friend Elnath. We talk about Elnath a lot in the V of Taurus. You got the V of the Hyades here. And if you extend those out, the northern branch of the V of the Hyades, the long stretch out here, that bright star you come to that marks the end of the run of Taurus there is Elnath, a nice bright 1.7 magnitude star. The moon will actually be very close to it. So that should be a nice pairing to look for at the end of the week. Check that out. Let's check mark that. That's a highlight. I like the moon near Saturn to begin the week too. So that's a couple of real highlights for the week ahead. As the moon gets later, as we get later in the week and the moon rises later and later at night, we have the opportunity to observe some deep sky objects in the evening sky. So the second half of the week in particular, we're talking about being able to see Scorpius. So Scorpius, late summer, Scorpius is great. We got the bright orange star Antares right here. And there's 3 stars that mark the head of the scorpion. And so we have these 3 stars right there, and then Scorpius. And we drop down to Eta down here, and then we have the big sweep of the scorpion's tail on down there. We didn't draw it. I didn't draw it because we won't talk about that. Maybe next week we can talk about deeper into the tail of Scorpius right here. But the 3 stars that mark the head, Beta, Delta, and Pi. If we start at Pi at the bottom, all of these stars are sort of 2-point-something magnitude stars. Delta's the brightest. I think it's 2.1 magnitude. And Pi's the faintest at 2.9 magnitude, I think, if I recall correctly. I didn't write it on the board, apparently, when we started. But we've got these stars are all brighter than 3rd magnitude, not quite as bright as 2nd magnitude. Big, bright stars right there. Pi is a spectroscopic binary. We've talked about spectroscopic binaries a lot. It's kind of fun to mention them whenever we kind of come across one, and we come across them a lot. So a lot of the stars in the sky, you look up, you look at the stars in the sky, you look at that, every half of the things that look like single dots to you are actually binary stars. So that means about 2/3 of the stars are in binary systems. And a lot of these binary systems are spectroscopic binaries, which means we see lines in the spectrum. If we break the light up into its components colors, we see dark absorption lines in there that tell us the temperature of the star and the spectral classification of the star, what kind of star it is. And we see those lines move back and forth. So oftentimes we'll see 2 sets of lines, and one of the stars will be coming toward us, be blue shifted, and one of the stars will be moving away from us. That line will be red shifted, it'll be longer wavelength. So we see these lines trade back and forth from shorter wavelength to longer wavelength as these stars orbit around us. So one star coming toward you, you get a blue shift, a shorter wavelength in the line. One star moving away from you, you get a longer wavelength, a red shift in the line. And we see that spectroscopic binary. We look at these a lot. 1.5 day period. So these stars are right on top of each other orbiting around to give us that spectroscopic binary for Pi. So if we jump up to Beta at the top, Beta is a nice bright 2.6 magnitude star. It's also a spectroscopic binary with a 6.8 day period. So you got the 6.8 day period, but it's also got other stars in the system that are resolved that we can see away from this primary star that is the spectroscopic binary. There is a star. It's a great binary double star for you to go out and look at with your small telescope. 13.7 arc seconds, easily resolvable. Any telescope you have, you should be able to split this. And it's a 4.9 magnitude companion, nice bright companion. So you should have no trouble seeing it again. Any telescope you have, you should be able to see this companion star. Is bright enough and it's far enough away from the primary star. There is actually a third star in there that's less than an arc second. You will not see that star. And so it's less than an arc second away from the primary star, and it's a 9.5 magnitude star. And so this is a very, very challenging star. And no sense even trying to see that one. So we got a multiple star system right there. Now, this region of the sky, we've talked about before, globular star clusters. These are the big hundreds of thousands of stars, 500,000 stars typically, let's say, in a globular star cluster. And they sit in a halo around the center of our galaxy. So if we draw our galaxy on here and we see this, we're out here someplace. These globular star clusters all look toward the center of our galaxy. And the center of our galaxy is right here. It's right above the tail of Scorpius and Sagittarius over here. And so we're looking in the direction of the center of the galaxy. We see all of these globular star clusters, and there are very famous ones, very bright, beautiful ones in Scorpius. Right next to Antares, a degree or so away, you've got M4. M4 is a big, loose, sprawling globular star cluster. It's bigger than just about any one you'll see, and there's stars sprawling out everywhere. M80, if you move up this direction about 4 degrees, just a little bit less than 4 degrees away from Beta, back toward the east, you're going to come to M80, and it's a much more traditional, tight, bright globular star cluster, but easy to see in your small telescope. You're out there taking pictures. Take pictures of these two and compare them and see what you think of those two globular star clusters. Now, if we drop down to Eta, we get two more really good examples of globular star clusters that look more like M80 than M4, sort of nice, tight, traditional globular star clusters. You've got M62 and M19. So you move up about 12 degrees, a little more. Remember, a fist width at arm's length is about 10 degrees. So a little more than 12 degrees from Eta to the north and back to the east just a little bit, and you come to M62. So scan up that way. You might be able to see it with your binoculars. Scan up that way, see if you can find M62, and then go about 4 degrees, again, a little bit less than 4 degrees, straight north from there to M19. And you've got two good, bright globular star clusters right there. So you compare these. You've got to take pictures of these too. You've got a great comparison group, M4, M80, M62, and M19 to be able to see right there. Now, M19 has a couple of nearby globular star clusters that are a lot more challenging. You got NGC 6284 to the northwest, about 2 degrees, a couple of finger widths at arm's length, about 2 degrees to the northwest of M19, and about 2 degrees to the west, east-southeast of M19. You're going to come to NGC 6293. Of these two objects, I think 6284 is the easier one to see. We talked about this a couple of weeks ago when we looked at a fainter globular star cluster like this, a more distant globular star cluster. 6293 is a little bit smaller and a little bit fainter, but it also sits in a richer star field. That is, there's a lot of stars in there, so you're looking for an increase in density of stars. You're looking for this globular star cluster to pop out on a bright star background, on a rich star background. This too has a rich star background, 6284. It's just not as rich, and it's a little bit bigger and a little bit brighter, this globular cluster. So I think you'd have an easier time finding this one, but go ahead and try them both. These are your challenge objects for the week, 6284 and especially 6293, and see if you can find those globular clusters, compare them to M62, M19, M4, and M80, and you're really starting to get a feel for what these globular star clusters look like toward the center of the galaxy, and getting a good sense of this region of the sky. Now, I should point out, M62 and M19 are actually across the border at Ophiuchus. We said we've got Scorpius here and Sagittarius here. Ophiuchus sits on top of Scorpius and Sagittarius, big sprawling constellation. And for M62, we've just barely crossed the border into Ophiuchus. M19's then, another 4 degrees up into the constellation of Ophiuchus. But that's what we got. That's great markers of the summer sky. Great thing to be observing in late summer like this as the moon wanes away as the week goes on. Be sure to check out Saturn as well. The Perseid peak is this night of I think we didn't mention that on the way by. On the night of the 12th into the morning of the 13th, with so much moon, this is a challenge. You should still be able to see some of the bigger, brighter meteors that are out there that the Perseids are known for. And so you'll see a handful of meteors, but it's going to be tough. You might be better off the next night. It's a big, long tube of material that we're moving through, so it's not just right at the peak. So early in the week, a lot of moon. As the moon wanes away, give the Perseids a shot. And then turn your attention to Scorpius and some of the globular star clusters in that region. And that's what we got. As always, thanks for watching, everybody, and we hope you have a great week ahead.